So we've talked about how your code could be slow because the type of hardware that's executing underneath it. Remember the whole floating point branching issue problem? Well, that's mostly a non-issue for today's hardware. There's one set of issues that you still need to worry about. That is the performance of the primitives in the language that you're using. Take a fundamental algorithm, such as sorting. Now, there are many ways in which to sort, and some are better than others, depending on the circumstances. For example, quicksort is generally faster than bubble sort, except when you have fewer than 1,000 elements. Or take searching for objects in a large sorted list. Generally, the best way to do this is with a binary search. But completely different is finding objects in an unsorted array. Now, instead of comparing each object for the value you're looking for, you can use a hash function to find it immediately. Now, this is all basic canon of modern computer science and data structures, and thankfully, modern languages like Java supply these containers and algorithms on your behalf so that you don't have to rewrite the murmur3 hash function or quicksort over and over and over again. But let me reveal something here. In all of my years of programming, the one problem that consistently bites performance of your project has to do with the performance of these language-provided container objects. I mean, it's awesome, right? Java is providing you with an implementation of a vector class so that you can push, pop, add, and remove objects as you see fit. But in order to get that flexibility, it has to use a linked list structure under the hood, which has a unique set of performance characteristics. As long as you're only operating on the front of the list, it's super fast. But if you're trying to insert or remove in other places, it's going to default to the worst possible time. The point is that just because the underlying system provides these containers doesn't mean that they're performant with respect to how your program is going to actually be using them. James Sutherland published a series of micro benchmarks on the performance of specific data structures provided by the Java framework, and found that there's some differences in performance versus functionality that people need to be aware of. For example, he found that hash table performance was about 22% faster than hash map performance, depending on how you're actually using the containers themselves. The point is this. Have you profiled your container classes that you're using in your code? Are you confident that they're using the absolute fastest container for what your code is actually doing? Yeah, that's what I thought. But the good news is that you can gain visibility into the performance of these containers with some handy profiling APIs in Android. So let's see if Chris's code stands up to our scrutiny.